Hello everyone, welcome to this tutorial. In this tutorial I'm going to run a simulation with DPM, discrete particle method, and let's start from a very basic geometry, and for that I'm going to make a rectangle. Let's make this 75 and the other side 50 millimeter. Then I'm just going to pull it on the Z direction for, let's say, 20. All right. And then I'm going to have some inlet and outlet. I am going to make a circle here. This plane, I'm going to put the rectangle here with the diameter of, let's say, 7.5, and then I'm going to pull this for 10. Yeah, and I'm going to do the same on this one and make this like an outlet. Very simple. And I'm going to put it here. $7.5. Then I can simply pull it. All right, this is my geometry. This is my inlet, this is my outlet, and let's just make some name selections. I start with this one. I call it inlet. This one I'll call it outlet. And the rest I can just call it walls. It doesn't really matter. Wall left, wall right, and this one I'll call it wall top, wall bottom, and these two walls I will call them wall, what should I call them? Wall, I just call them wall, it's okay. All right, this is my geometry and I'm ready to go to meshing. I just close it. Then I start this beautiful meshing tool for Fluent. All right, so let's start with import geometry. I'll just click on import geometry so that I get my geometry imported. Let's see. It's going to take a few seconds. Cool. Now the geometry is imported. You can see it. We have inlet on the top left and the outlet at the bottom of the geometry. Then I'll just add some local size. Let's just put some local size to the wall left. I make it to target mesh size of 0.8 to the power of -5. This is good. And then the next step is to generate the surface mesh. Let's just make these numbers a little bit. All right. Rounded, and then click on generate surface mesh. You can see that the surface mesh is being generated. We have to wait for a few seconds, I guess. 75%. And I guess we have, all right, we have the surface mesh now, and then we describe the geometry. The geometry consists of fluid regions with no voids. The rest is no. Change all fluid boundary types from wall to internal. No. Do you want to apply shear topology? No. And multi-zone meshing, I'm not interested. So, right. The inlet is velocity inlet. These are the boundary conditions. The outlet is pressure outlet. The rest are just basically walls. This is good. Update region, solid is fluid. Excellent. And then add some boundary layers. I would like to have number of layers to 5. Transition ratio is fine. And yeah, add boundary layers. And then on the last step, I would like to fill it with hexacore. I think I'm going to modify the maximum cell length to 0.002. All right, let's generate it. %10 done. This is actually quite fast. I'm happy. Cool. This looks really nice. We have beautiful boundary layers, and this looks fantastic. I think this is great. If we check the quality as well, validate the volume quality. Yeah, so the cell quality maximum and minimum, you can see it, and the average. I think this is just fine. We can just close it. Form mesh. All right, let's just close it and get quickly back to Ansys Fluent itself. Now I click on setup. I think I'll just increase it to 20 number of cores. Start. Let's just click on double precision as well. Actually, a lot of number of nodes. It's around 2 million nodes, but that is fine. We can live with it. So this is a transient simulation. I'm going to activate the gravity minus 9.81. And then the model, I'm going to use viscous SSTK omega. Let's just change the material first. I click on Fluent database. I'll go all the way to the bottom and then the water liquid. Copy it. And then you can change the fluid in the cell zone condition. Double click on that and then from air to water liquid, and that is good. Now everything is changed to liquid. So in the discrete phase, you click on injection and then you create a new one. I will call it injection inlet. Okay, this is just the name. And then you have several options. You have particle type, which is massless and inert or inert. And then you have point properties, injection type. I would like to have the injection type as a surface at my inlet. So I'm going to inject particles from the surface of the inlet. So this is the way that you do it. And then I have to specify the x velocity of 1 meter per second. You can change the diameter to, let's say, 0.001 meter. Start time 0, since this is transient, and the stop time, I would put it at 1. You can select the scale flow rate by phase area, that is fine. And then the rest, I think I would keep it as default. And then you just click on OK. The next step is to define the boundary condition. I'm going to change the boundary condition of the inlet. Where is the boundary condition? The boundary condition is right here. You click on inlet, and then the velocity magnitude is the same as my particle velocity, which is 1 meter per second. Okay. And the valves are valves. The outlet is at 0 gauge pressure, which is fine. I'm not going to touch it. And then you can go to solution. Before initializing, you can go to solution, or actually you can go to results. You can show your mesh, and instead of showing the faces, you can show your edges, and this looks good, right? Because now you can see whatever is inside this. So what I'm going to do is I'm going to make a simulation. I'm going to make an animation. And for that, I have to initialize my simulation first. So I go to initialization. I use the hybrid initialization, and then I just click on initialize. The solution is now initialized. Then I click on particle tracks and click on new. I click on injection and just save and display. So since this is at time 0 and this is initialized right now, there is nothing to show, but that is fine. The next thing that I'm going to do is I'm going to basically make a scene out of this. So on the graphics, I click right click, and then I click on scene, and then I click on mesh and particle track number 1, save display, and now you have a scene, right? Which is showing both mesh and particle tracks. Then in the solution, I'll go to create under activities, and then I make an animation, solution animation for scene 1. So you click on scene 1, and then you basically auto save the simulation results every time steps, and then I click on OK. Now I can run calculation. This is a transient simulation. I'm running it for, let's say, time steps of 0.02 seconds, and I'm going to run it for 50 seconds, which gives me 1 second in total, right? and then I can click on calculate, and we can see how the results looks like. Simulation is starting. Now you can see the first particles introduced to the system. I'll wait few iterations more, and then I'll just going to pause the simulation and show you the final results at the end of this video. So now you can see that the second particle is injected to the system. I'm going to just pause this video, and I'll show you the final results at the end. All right, talk to you in a few seconds. All right, the simulation is now finished. We had 1000 iterations, and this is the final configuration of particles in the system. If you want to look at the video, you can basically go to scene, double click on that, and I mean basically actually you can go to the animation, solution animation, double click on solution animation. Sorry, you can go to results, animation, and then playback, and then you can just start it from time 0. You can see how the particles are distributed in the system. Let's look at for example, the vector plot and see how the velocity in the system matches with the particle in this geometry as well. For that, I'm going to go to results. I'm going to create a plane. That should be an XY plane, and I think the Z.01 is just fine, and then you click on create, and once plane number 9 is created, you can go to vectors, create new, velocity is just fine, I mean actually plane 8, save and display. Scale is a little bit big, I just make it 0.5, and then you can see that you have velocity coming into the system, into the geometry, and then you have a circulation on the top and another circulation at the bottom, and that is exactly the way that particle is moving inside the system, if you remember the video. And this is small recirculation, and then here is the outlet. I hope you have enjoyed this video. Until next tutorial, talk to you later.